Okay, my dear students, you would have watched video number 1, that is nothing but physical properties of metals and non-metals, right? So now in the video number 2, we are going to learn about chemical properties of metals and non-metals. Okay, so in that we have first one, reaction with oxygen. Meaning what happens when metal reacts with oxygen, or what happens when non-metal reacts with oxygen. Okay, so now let us enter into our video. You are familiar with the phenomenon of rusting of iron. Yes, what do you mean by rusting of iron? Yes, you can see a photo in your screen, right? So this is nothing but a iron nail, correct? This is nothing but an iron nail. So this is an iron nail. This one is a rust iron nail. After rusting, you can see some reddish brown coating on an iron nail. So initially, your iron nail was showing a physical property called luster. But why it has changed into this form? That is what we are going to study. Actually, when this iron nail is exposed to open air, meaning what? You all know in our air we have abundant oxygen gas. So this oxygen gas will be reacting with the iron nail when the iron nail is placed in the open environment. So when oxygen and iron reacts with each other, we can see the formation of a reddish brown rust on it. Okay, so now you got the meaning of rusting of iron, right? Yes, now let us enter into a next activity. So the activity is that let us check the nature of rust formed as a result of the reaction between iron, oxygen and water. Yes, as I have shown you the picture of rust, how the rust looks. Rust is nothing but something which is a reddish brown coating present in the iron nail, because the iron nail would have reacted with the oxygen as well as with the water. So now I am going to check the nature of the rust. Nature of the rust in the sense, I am going to check whether the rust is acidic or whether the rust is basic. So we are going to find whether the rust is acidic or whether the rust is basic. So what I am going to do is that collect a spoonful of rust and dissolve it in a very little amount of water. Yes, I am going to scrap all the rust present in the iron nail and I am going to dissolve a little amount of water to the rust. See, this is a test tube where I am having both rust dissolved in water. You will find that rust remains suspended in water. Yes, so when water is added to the rust particles, the rust would have not completely dissolved. So what I am going to do is that I am going to shake the test tube well. So when I shake the test tube well, some rust particles would have got dissolved in water. Now what I am going to do is that I am going to take litmus paper. Now the question arises in your mind, what is this litmus paper? Yes, this is what litmus paper which you are seeing in the screen. It is an ordinary strip of paper, right? Which is in this rectangular shape. So what is the role of this paper? Means this paper detects whether a given solution is acidic or base. Suppose if I am having a solution in a beaker, I don't know whether this solution is acid or base. In order to check whether it is acid or base, I am going to take a litmus paper and I will dip it in this solution. When this litmus paper, when blue litmus paper, this blue litmus paper is turning to red color, when I dip it in the solution, then I can say that the given solution where I have dipped my litmus paper is acidic. It's a very important one. When blue litmus turns to red color, then the given solution is a acidic one. Suppose if I take another beaker and if I dip a litmus paper, if that red litmus paper, this red litmus paper is turning into a blue color, if this red litmus paper is turning into a blue color somewhat like this, if it is turning into a blue litmus paper, then I can say that the solution present in this is basic. So from this what I can infer? I can infer that whenever a blue litmus paper is turning into a red color, then the given solution is acidic, or whenever the red litmus paper is turning to a blue color, the given solution is basic. That's what litmus paper role. Now coming to this activity again. So as I said, I am having a test tube where I am having a rest as well as water dissolved in it. So I am going to take some plate. In that plate I am going to pour the solution. Again I am going to dip a litmus paper, red litmus paper. Do you know what is the color change? Yes, the red litmus paper which I have dipped in this hydrated rust will has been turned into a blue color. Meaning what? When red litmus is turning into blue, I can say the rest which is dissolved in water is basic. So the nature of rust is basic. Understood this activity? Okay, fine. Now let us enter into the next chemical property of a metal when it reacts with the oxygen. Okay. Now what happens when magnesium ribbon is heated in presence of oxygen? When magnesium ribbon is heated in presence of oxygen, a white ash powder is formed. So how it is formed? Let I share you a video. Okay, so let us see what happens when magnesium ribbon is heated in presence of oxygen. When magnesium ribbon is heated, look here what happens. So this is what the magnesium ribbon. Okay, so I am taking a magnesium ribbon in my hand. So look here, this magnesium ribbon, I am heating it. When I heat, I am going to get a dazzling flame. In the sense, magnesium ribbon is burning vigorously. Now, after it has completely burnt, the magnesium ribbon has turned into the ashes. Correct? Ashes in the sense like a powder type. So look here, I am going to place the powder type in the china dish. The ribbon has been turned into the ashes like this. Correct? So that is what this activity means. Okay, the ash what I obtained after heating the magnesium ribbon, if I dissolve that ash in water, and when I test the nature of the ash which I have got it, in the sense when I dip the litmus paper, when I dip the red litmus paper, so for example I'm taking a test tube. In that test tube I added water. To that water I am going to add the ash which I have obtained on burning the magnesium ribbon. So when I dip the litmus paper, red litmus paper, when I dip the red litmus paper inside this test tube, your red litmus paper will be turning into a blue color, which indicates that the ash what we obtained when we heat a magnesium ribbon is basic in nature. So the ash which we obtained when we heat the magnesium ribbon is basic in nature. Now let us learn the word equations now. Okay, so we have learned two activities. One is about rust, second is about ash which is formed on the burning of magnesium ribbon. So first word equation is that when iron, remember iron chemical formula is Fe, oxygen chemical formula is O2, water chemical formula you are all aware it is H2O. When iron, oxygen and water is combined, The product what we will be getting is rust. The product what we'll be getting is a rust. Rust is also called as, please make a note as a running note, rust is also called as hydrated ferric oxide. Rust is also called as what? Hydrated ferric oxide. Okay, hydrated ferric oxide. So when iron reacts with oxygen and water, will be forming a rust, and that rust nature is basic. Similarly, when the magnesium ribbon is heated in presence of air, means if it is heated in presence of oxygen, the product what we are going to get is ash. Correct? That ash is nothing but, chemically it is called as magnesium oxide. Okay, the ash is nothing but magnesium oxide, and the nature of ash, that is magnesium oxide, is again basic in nature. We have performed an activity now. So generally what I can say, all the oxides of magnesiums is basic in nature. Meaning what? All the metallic oxides are basic in nature. All the metallic oxides are basic in nature. One more question they may ask. Metallic oxides are dash in nature. It is basic in nature. Correct? Magnesium oxide is also a metallic oxide. Aluminium oxide is also a metallic oxide. Sodium oxide is also a metallic oxide. So generally all this metallic oxide, when I dip a litmus paper in this metallic oxide, the red litmus paper will be turning into blue, which indicates that all these metallic oxides are basic in nature. Okay, so now let us go on with the second property of the metals. Before going with the second chemical property, let us learn how a non-metal reacts with the what is that? How a non-metal reacts with the oxygen. So when a non-metal reacts with the oxygen, we have an activity here. So in this activity, I am going to take a deflagrating spoon. This is called as deflagrating spoon. Here you have a spelling. Deflagrating spoon. Deflagrating spoon. So in this deflagrating spoon, I am going to take a non-metal. You all know sulfur is a non-metal, right? So when I am going to take sulfur, and if I am heating it, if I am heating the sulfur in presence of oxygen, means when I am heating it in the open air, what happens? A gas will be evolved. So what I'm going to do means I'm going to take a jar like this, and I'm going to allow the gas to fill in this jar. I'm going to allow the gas to fill in the jar. At one certain point, I'm going to take this deflagrating spoon out. So all the gas will be present here. Now, if I check, or if I dip the litmus paper in this flask, do you know what will be the color change? Yes, the blue litmus will be changing into the red litmus. Meaning what? The gas which we obtained on heating a non-metal called sulfur, the nature of the gas is basic. The nature of the gas is basic. So whenever a non-metal is heated, we will be getting again a non-metallic oxides, and all the non-metallic oxides which we are getting is acidic. So the non-metallic oxide which we got was sulfurous acid. Actually, in this activity what we are going to do in the sense, see, we are going to collect the glass in the glass vessel. After collecting all the gas, I am going to add water. Okay, after collecting all the gas, I am going to add water. Then I am going to dip the litmus paper. In the beaker containing both water as well as the gas when sulfur has heated. So when the gas and the sulfur has heated, we'll be getting an acid called sulfurous acid. Since sulfurous acid is formed, that is why the blue litmus paper has turned into red. which indicates that acid is present in the given solution. So the gas which we obtained on heating the sulfur is sulfur dioxide. Chemical formula of sulfur dioxide is SO2. When this sulfur dioxide, the gas which we obtained on heating the sulfur, when it is again reacted with water, we'll be getting an acid. That is why when I dip the litmus paper, I am getting the red color litmus. Now we are going to learn about the second property, reaction with metal. See, the sodium metal is very reactive. Okay, it vigorous means violent. It violently react with the oxygen and water. So lot of heat is generated in the reaction. Therefore, always the sodium metal is stored in kerosene. See, the sodium metal is very reactive. It is a highly reactive metal. When I keep a sodium metal in an open air, there is a chance that sodium metal will start to burn itself. Or when I keep the sodium metal inside the water also, the sodium metal will start to burn, because this sodium metal is highly reactive to oxygen and water. So we cannot keep the sodium metal in open air, as well as it cannot be kept in the water. That is why all the sodium metal which are highly reactive is usually stored in kerosene, because sodium metal is very less reactive in kerosene, whereas sodium metal is highly reactive in oxygen as well as with water. That is why the sodium metal is not kept in open air, as well as it is not dissolved in water. So you have to remember that point. Okay, so now let us learn what happens when the metal reacts with water. So as I said, sodium will react vigorously. It will react violently with water. But whereas iron will react with water very slowly. The vigorous will not be very high. It won't be very violent as in case of sodium. So what about non-metals? These non-metals, usually they do not react with water at all. Okay. So this non-metals react with the oxygen. This non-metal react with the oxygen. But whereas this non-metal will not easily react with the water to obtain any products. Okay. Then this phosphorus is a very reactive non-metal. Whereas this phosphorus is a very reactive non-metal. In one mark question they may ask, which is a very reactive metal. If they ask dash is a very reactive metal, your answer should be sodium. If they ask metal. If they ask dash is a very reactive non-metal, your answer must be phosphorus. P is the short form or the chemical formula for phosphorus. Sodium chemical formula is Na. Sodium chemical formula is Na. Please do remember. Okay, so this phosphorus will highly reacts with atmospheric oxygen. So I cannot keep the phosphorus in the open air, because when phosphorus is kept in an open air, it will react with the air and there is a possibility of catching fire. So I can place this phosphor inside the water, because phosphor is least reactive with water. As I said, non-metal does not react with water. Since phosphorus is also a non-metal, it doesn't react with the water. Now, third chemical property of metals and non-metal is that reaction with acids. Now, let us learn how the metal and non-metal reacts with acids now. Okay. Remember students, whenever whenever the metal reacts with any acid, see, hydrochloric acid is one example of a acid, dilute hydrochloric acid. What do you mean by dilute hydrochloric acid? Hydrochloric acid means it is an acid, and chemical formula for hydrochloric acid is, please remember, HCl. Dilute hydrochloric acid means the hydrochloric acid which is dissolved in water. The hydrochloric acid which is dissolved in water is called dilute hydrochloric acid or dilute acid in general. Remember, whenever the acid or base, when it reacts with metal, when it reacts with metal or when it reacts with a non-metal, the product what we'll be getting is that we'll be getting a salt, any salt depending upon the acid and base we used, along with the gas called hydrogen. So one more question again. Name the gas liberated when acid reacts with the metal. When acid reacts with the metal, we will be getting a salt as well as a gas called hydrogen. H is the chemical formula for hydrogen. So how we came to know that hydrogen gas is only liberated in this reaction? For that we have an activity. Have a look on this activity. So as I said, whenever a metal reacts with acid, we'll be getting salt as well as hydrogen gas. How we came to know that only hydrogen gas is evolved? Make a look in this activity now. See, I am going to take a test tube. In that test tube, I am going to add dilute hydrochloric acid. To that dilute hydrochloric acid, I am going to add a burner. Before that, I am going to light the Bunsen burner. Let I light it. So this is what Bunsen burner. Okay, now let I take the test tube again. Now to that test tube, I am going to add a metal. Magnesium ribbon is a very good example of a metal, right? So when I add a metal to the acid, as you can see below, the product are salt and hydrogen gas. Now to check that hydrogen gas is only liberated, I am going to bring a burning candle near that. Can you hear a sound? That sound, please watch it again. Yes, this sound is, yes, that sound is called as pop sound. So, yes, this pop sound indicates that, the gas liberated during the reaction of acid and metal will always give hydrogen gas. Okay, we have learnt that what happens when a metal reacts with acid. Correct? So when a metal reacts with acid, we will be having a pop sound. That pop sound indicates that, what it indicates? That pop sound indicates the gas which is liberated. The gas which is liberated is an hydrogen gas. Similarly, what happens when metal reacts with the base? What happens when a metal reacts with the base? As I said earlier, hydrochloric acid is an example of acid. Can you give any example of a base now? Can you give any example of a base? Yes. Sodium hydroxide. Short form for sodium hydroxide is NaOH. So sodium hydroxide is a very good example of a base. Now what happens when a metal reacts with base? Yes, when a metal reacts with base, we will be getting same salt as well as hydrogen as in case of reaction with acids. Adhe tara, we will be getting a pop sound, which indicates that hydrogen gas is liberated when metal reacts with base. Okay, so again we will be hearing a pop sound, because when metal reacts with base, we will be getting getting salt and hydrogen gas will be liberated. But the salt will be very much complex. The product of the salts are complex. Okay, now coming to the last fourth chemical property of metals, that is displacement reaction. So let us have a look on displacement reaction now. Okay, you can see a picture in your screen, right? So this is beaker A, this is beaker B, C, D, E. And in beaker A, what we are having, in beaker B, in beaker C, D and E, what are all the components present? They have given in this tabular column. Now you can have a look. In beaker A, I am going to take copper sulfate solution. Chemical formula of copper sulfate is CuSO4. The color of copper sulfate is blue in color. So when this blue color copper sulfate, for this blue color copper sulfate, if I had a metal called zinc, zinc is a metal, Zn is the chemical formula. If I add zinc to this copper sulfate solution, the solution turns into this color. The blue color of the solution has turned to this color. Why the color has changed? The color has changed because of displacement reaction. Now we are going to study what is the meaning of displacement reaction. Please guys, have a textbooks on your hand. Whatever I am underlining, you are also supposed to underline. Okay, so displacement reaction means what? Let I take the first example itself. See, the first beaker, I am going to take copper sulfate and zinc. In this copper sulfate, this metal will displaces the another metal. Andre copper sulfate alli, have a look on this properly. Copper sulfate alli ನಾವು copper metal na remove ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ zinc ಬಂದು attach ಆಗಿದ್ರೆ will be getting what? We will be getting, okay, so look here, this copper remove, it will be removed. In that place zinc will be added. So if copper is removed and zinc is added, means what is the product we are going to get? We are going to get the product called zinc sulfate. Correct? We are going to get the product called zinc sulfate. That's what given here. ZnSO4 means zinc sulfate. So when copper is removed and zinc metal is added, when one element or one metal is displacing the another element in an another metal, that is called as displacement reaction. Have a look on this beaker B again. In this copper sulfate solution, if copper is removed, and if iron metal is displaced in place of copper, displace madidre, what are the product? Iron sulfate. Remember students, iron is also called as ferrous. Iron is also called as ferrous. So when iron is displaced in this reaction, the copper is removed, we'll be getting what? We'll be getting ferrous sulfate. Iron means ferrous, right? We'll be getting ferrous sulfate. That is what given here. FeSO4 means ferrous sulfate. So displacement reaction means that only. One metal will be removed. The metal what we add will be displacing in that removed place. Getting what? Iron sulfate. Okay. Now what about the third one? Look at the third one properly. When I add zinc sulfate, okay, and if I add copper turnings, if I add copper to zinc sulfate, there will be no change. Look here. Only the first two beakers has been changed this color, whereas the third, fourth and fifth has not changed anything. Why? Why means this copper is less reactive. This point is very, very important. This copper is less reactive. If this copper is less reactive, this copper cannot displace, it cannot remove the zinc. Andre copper ge ashtu shakti iralla zinc na remove madake, whereas in first two cases zinc and iron has the power to break the copper from the salt solution and it gets joined to form zinc sulfate and iron sulfate. Adre copper ge ashtu shakti iralla because copper is very less reactive. Since it is very less reactive, it will not remove the zinc from the salt. ಜಿಂಕ್ ನ ರಿಮೂವ್ ಮಾಡೋಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ, ಯಾಕಂದರೆ ಇದು ತುಂಬ ಲೀಸ್ ರಿಯಾಕ್ಟಿವ್, ಇದು ತುಂಬ ಲೆಸ್ ಪವರ್ ಇರುತ್ತೆ. ಸೊ ಸಿನ್ಸ್ ಕಾಪರ್ ಇಸ್ ನಾಟ್ ಹ್ಯಾವಿಂಗ್ ದಟ್ ಸ್ಟ್ರೆಂತ್ to remove the zinc, it will not displace, the copper will not displace, henceforth there will be no change in the beaker C. Similarly, what happens is that again when I add copper turnings to the iron sulfate, as I informed here, copper is very, very less reactive. It doesn't have that strength to remove the iron from iron sulfate. Iron sulfate in the iron ರಿಮೂವ್ ಮಾಡೋಕ್ಕೆ ಈ ಕಾಪರ್ಗೆ ಶಕ್ತಿ ಇರಲ್ಲ, ಯಾಕೆಂದರೆ ಕಾಪರ್ ಇಸ್ ಲೆಸ್ ರಿಯಾಕ್ಟಿವ್. ಸೊ ದ ಬೀಕರ್ ಕಲರ್ ವಿಲ್ ನಾಟ್ ಬಿ ಚೇಂಜ್ಡ್ and the reaction between copper and iron sulfate will also not takes place. Similarly, this sixth one, iron nail and zinc sulfate, ಅದೇ ಥರ iron is not very reactive, is not very highly reactive. Okay, iron is also a less reactive metal such that this iron will not remove the zinc from zinc sulfate and the iron will not displace in the sulfate. Got it clear? So the order of reactivity I says that copper is very less reactive. Copper next to iron is very reactive. Iron is nothing but ferrous. Next, zinc. So this is the strength of the metal. Copper is very less strength. ಅದಕ್ಕಿಂತ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಸ್ಟ್ರೆಂತ್ ಇರೋದಂದರೆ ಫೆರಸ್, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಸ್ಟ್ರೆಂತ್ ಇರೋದು ಜಿಂಕ್. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಕಾಪರ್ ವಿಲ್ ಬಿ ಲೆಸ್ ಸ್ಟ್ರೆಂತ್, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇರೋದು ಫೆರಸ್, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇರೋದು ಜಿಂಕ್. ನಾವು ಕಮಾನ್ ಆನ್ಸರ್ ಅಮಾಂಗ್ ದಿಸ್ ತ್ರೀ ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್. Very good. Zinc is more reactive. Among three, which is very less reactive? Very good. Copper is less reactive. So this is what displacement reaction means. Okay, so lastly we have uses of metals or non-metals that you continue to watch an animated video in next video number 3. So all of you don't forget to watch the next video number 3. By that video number 3, the chapter called materials, metals and non-metals ends. Tomorrow, that is on 8th September, Wednesday, I will be sharing you, I'm sorry, not 8th September, that is 9th September, Wednesday, I'll be sharing you the classwork notes. Thank you all.